Hello, is it working? It is working. Hello, Bridge. How are you doing? I got another one for you, and check it out. I got cool new font. Thought that was pretty cool. Wanted to share. All right. So I have a real world example that we may run into later. We've also done these before. Good one to keep in your brain. So a certain drug decays at a rate of 15% per hour. If the initial dose, hey, that might be an A value, right? A starting point. Initial dose is 500 milligrams, and it is not safe to drive until there is only 50 milligrams left in the person's system. Will it be safe to drive after 5 hours? And there is our time, okay, our time. So we know that, what am I doing here? Let's say y, I like y. Y equals some sort of initial deposit or initial amount, right? And we have that value 500. And we've used, hang on, I'm just going to write this all out. Y equals P times 1 plus or minus R to the power of T. That's what makes it an exponential. So here's my initial value. So I'm going to have Y equals, I'm just setting up a basic function that we could use. We have to decide if we are going to use plus or minus here. And since it is decaying, we see that decay rate right here, we're going to use 1 minus R. And in this case, R is 15%. So 15% as a decimal off to the side. 15%, I'm going to take that decimal point, move it twice like that. So I'm going to have 1 minus 0.15 to the power of T after 5 hours T to the power of 5. And now we can evaluate this down, okay? So I'm going to have Y equals 500. 1 minus 0.15 is 0.85 to the power of 5. Okay, I did a calculator. And 0.85 to the power of 5 is 0.4437, about 0.4437. And then multiply that by 500. Multiply that by 500 times 500, my initial deposit, or initial amount, excuse me. You're going to get 221. 221. So after 5 hours, after 5 hours, we're going to have 221 milligrams left in the bloodstream. Will it be safe to drive after 5 hours? No. Do not operate heavy machinery. All right, so there we go.